Well, hello, hello, all my beautiful AP Calculus students. Today we are going to go into the drop box provided by AP Central. Let me see, this is our IP address for that. And you can see this up here in my screen. So I'm just going to hit enter and go straight to that drop box. It says AP Calculus AB Spring 2020. I'm going to go to the 7.3 March 27th drop box. And we have two different things in here that I want to play with. They're both the same thing, but I think this one over here, the one that says card match with answers, obviously has answers. I don't think this slope field card match has any answers. And this one here is the slope field card match as well. So I'm going to click on this here. It's going to say open in a new tab. So I'm going to go ahead and open it in a new tab. And you can do this at home. This is through Desmos, so you see it has a page 1 and a page 2 is check yourself, which we'll do, but first we'll play with the slope fields. Okay, here we go. We have a bunch of differential equations, and I'm going to use my clicking feature on my computer to click and drag, click and drag. I'm going to take all my slope fields, I'm going to pile them over here on the right-hand side, just to get them all together. And I'm going to take all of my differential equations and piling them on the left-hand side. Okay, so let's do this. Let me grab this one over here, bring this over, grab this one. So I have a whole bunch of, yep, I didn't mean to click on that like that. Let me see, put this one in here, drag this one over, another one hiding in there, drag that one over. Here we go. So I'm thinking now, yep, all 14 slope fields are together in here. And all, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14 differential equations are on my left-hand side. I'm going to organize these together just a little bit because it seems like some of them look alike. Let me see, I see this fraction over here with x over y, and then I see another fraction with y over x. I'm going to kind of put those together. Here's negative y over x. Here's negative x over y. So I think these four kind of have something in common with their ratios. Let's look and see if we can find anything else that looks alike. Let me see, I'll pull this one away a little bit. I have xy plus y squared, and over here I see xy minus y squared. I think those are kind of alike. I see an x plus y here. Let me see. Yeah, here's an x minus y. I'm going to pull that up in there. Okay. Let's see what else. Let me see. X squared plus xy, x squared minus xy. Those are kind of looking like each other, aren't they? And, oh, here we go. X squared minus 16, x squared plus, oh, let me see. Nope. Y squared minus 16. Put those next to each other. And then these two here, let's see, well, I think they kind of have something alike. Matter of fact, all four of these things right here, all four of these differential equations are somewhat alike compared to the other, what do we have, 2, 4, 6, compared to the other 10 over here. These four differential equations are kind of alike because this particular one only has x's in the right-hand side of the equation. This particular one only has x's on the right-hand side of the equation. This particular one only has x's on the right-hand side of the equation. And the last one only has y's on the right-hand side of the equation. So all four of these slope field, I mean, they're not slope fields, they're differential equations that represent slope fields. All four of these differential equations are only with respect to one variable, whereas all of these others here, they're with respect to x and y both. So how does that matter? Let's take a peek and I'll show you exactly why and how that matters. Okay, I'm going to break apart some of these cards and I'm looking for something in particular, and I'll show you what I'm looking for that is going to correspond to these four differential equations. If I open this one up, I just picked any slope field to open up just so we can talk about it. And I'm just going to pick a random number like x equals, let's say 2. When x equals 2, notice I'm here on my x-axis at 2. As I go up or down, I have different tick marks in my slope field. So therefore, when x is 2, it'll matter what the y value is as I move up the y-axis, or if I move down the y-axis, the tick marks are changing, which means the slopes are changing because each one of these tick marks represents a slope. A horizontal tick mark represents a slope of 0. This tick mark right here represents a slope of -1. This tick mark represents a slope of 0. This tick mark, I can't really quite tell. It might be a slope of 3 or 4 or 5, but it's a positive slope that's bigger than 1, which is more important, okay? This is a positive slope that was bigger than the previous one, and so on. These are getting really, really big positive. This might be like a slope of +10 or +15. I don't know. It doesn't really matter. It's just a really big positive slope. Point is, as I scroll up and down when x equals 2, my y's matter because my slope is changing depending upon what y value I happen to be on. As I scroll left and right, let's do 4, y equals 4. If I scroll left and right at y equals 4, of course moving left and right means that my x value is changing as my y value stays at 4. You see the tick marks are different? So that means that when y is 4, the x's matter. So given a particular x, the y matters. Given a particular y, the x matters. That means that this particular slope field that I'm looking at right here has to match one of these other cards over here. One of these 14 cards. I'm sorry, 10 cards. Has to match one of these 10 cards because the x and the y are involved in the differential equation. So I'm just going to put this one to the side right now, and I'm going to try and pick one of these cards where as I scroll up and down for a particular x value, I maintain the same tick mark. And as I scroll left and right, I maintain the same tick mark. I should say, or as I scroll left and right. So this doesn't work. Both x and y are involved in this particular function. I'm going to move it back over here. I'm going to move this one here. Up and down, we're changing. Left and right, we're changing. That means both the y and the x are involved in the tick mark, in the differential equation. This one looks kind of interesting. So I'm going to blow this up so you can see. If I picked, let's say, x equals 2 again, and I go up or down at x equals 2, I can see that those tick marks are different. Each one is different. So that means that the y value matters because going up and down makes a difference. So going up and down is y, which means changing the y value changes the slope. If I were to take, let's say, y equals 2, and I scroll left and right, and you see that every single one of these tick marks is identical. So when y equals 2, I get a certain slope regardless of what the x is. So in this particular slope field, the x is irrelevant. The slope is not dependent upon the x. The slope is dependent upon the y. So this has to match some differential equation that has y's in it but has no x in it. So we only have one of those. It's right here. This particular differential equation has only a y value. It does not have an x value on the right-hand side of this equation. So let's look at this as well. Let's compare these two, and we'll see they do indeed match. If I were to let my slope equal 0, and I were to say 0 equals, I would factor this side of the equation because it is a quadratic, and I want to try and solve it. This right-hand side of y squared minus 16 will factor into y plus 4, y minus 4. Put those factors individually equal 0 by the zero product property, and you would get y equals plus and minus 4. Well, look, when y equals positive 4, my slope does indeed equal 0, which was the presumption that I used. I put a 0 in for dy dx in order to solve for y. So this matches. Down here at negative 4, same thing. When y is negative 4, the slope is 0. So this slope field matches this differential equation. And if you want, you can test by picking another point. You could pick, let's say, let's blow this up. Let's pick the point, I don't know, 6, 3. 6, 3 is right here. So if I take 6, 3, and I put 6, 3 into this differential equation, notice the 6 doesn't matter. So all I have to do is square 3. That gives me 9. 9 minus 16 is negative 7. And sure enough, let's go back to this. At 6, 3, does that look like that could be a slope of negative 7? And I would say, yes, indeed, I would argue that it is. So you could pick any xy coordinate point, plug the xy values into the differential equation, and see if the slope looks like the slope of the tick mark. And it definitely does. So we're going to go ahead, we're going to match that card to that slope field. Okay, so those are two matching cards. Now I'm going to continue to search for something where if I scroll up and down and left and right, I am constant one direction or the other. Like this particular card, I can see this. It comes out quickly to me. You see this row of horizontal, this column, I'm sorry, of horizontal dashes? This particular column of horizontal dashes and this particular column of horizontal dashes and this particular column of horizontal dashes, they're occurring at -4, 0, and 4. So again, going up and down tells me that whatever movement up and down I'm making doesn't matter. So the y's don't matter. It's moving from left and right that changes the slope. See, as I move from x equals 4 to x equals 2, I get a different slope on my tick mark. So that means that this particular differential equation that matches this slope field is going to be all in terms of x's, and the y's won't matter. Going up and down doesn't matter. Moving left and right makes a difference as to what the slope is. So I'm looking for something with all x's and no y's. Well, let's close this off and let's see. That's one of these three over here. So it's either going to match the top one, the middle one, or the bottom one. And I have 3 x values where my slope would be 0. I have plus and minus 4, and I also have x equals 0. So x equals plus and minus 4 would definitely be a solution to this differential equation when the derivative is equal to 0. If I were to set the top card up here, if I took a 0 for my dy dx, I set 0 here. I'd like to write equals 0 over on the right hand side. Factor out an x, and I get x, open parentheses, x minus 4. That'll give me x equals 0 and x equals 4, which would work if x equals 0 and x equals 4 were the only two places where you saw the horizontal tick mark. But I see a horizontal tick mark over here, -4 as well. That leads me to this card right here. This card would give me, if I put a 0 in for my dy dx, meaning I want my slope to be 0, so I'm wondering where would my horizontal tick marks be. I would factor x squared minus 16 to give me x plus 4, x minus 4, and then I would have 3 factors that I'm setting equal to 0. When I write 0.5x equals 0, that will give me x equals 0. If I put x plus 4 equals 0, that'll give me x equals -4. And if I put x minus 4 equals 0, that gives me x equals +4. That gives me 3 possible solutions where my derivative or my slope would equal 0. This is the card right here that has to match this particular slope field. Do we see it? We're going to have 2 solutions for a 0 slope from x squared minus 16, and we're going to have another solution. It's going to be x equals 0 from the 0.5x. All right, so these 2 cards definitely match. Let's condense them, and let's put them down here. Now I'm trying to find 2 more slope fields where my y's don't matter. Let's see. Oh, I don't know about you, but I recognize this slope field from the AP Central video that they did. All right, here's a good card right here. Let's move this together with this, and let's move these right in here for a minute. Okay, I'm going to try and condense this to make sure I don't lose this particular card right here. There you go. Okay, what do we have? Notice as I move up and down at x equals 4 and up and down at x equals -4, my slope is a 0. So I'm looking for a differential equation where I only have x's and I don't have any y's. No matter what x value you pick, if you go up and down, going higher or going lower does not have any effect on the slope of the tick mark here, the tick mark. So this is going to match something where x equals -4 and x equals +4 gives you a 0 slope. I'm hoping we've already conversed about that and you realize that this is definitely the slope field that we're going to be, the differential equation that will match this slope field. Okay, so we're going to pair those up, put them together, and slide this down. I'm looking for one more slope field that will match this differential equation, and it happens to be visible right here, so I'm going to grab it and bring it over. I noticed it really fast because I saw these horizontal tick marks up and down the y-axis, which is the equation x equals 0, and also x equals 4. So notice that if you were to set dy dx equal to 0, factor out an x, you'd have x times x minus 4. That would leave you with x equals 0 or x equals 4. This slope field definitely matches this differential equation. We're going to pair those up, and we are going to condense them and move them to the side. All right, now I have all of these other differential equations that I need to play with. And I'm going to look to see some characteristics that are like in different slope fields. So for instance, I see that these two cards right here, if you look up and down the y-axis where x equals 0, and you look up and down the y-axis where x equals 0, I see that I have a 0 for slope. So letting x equals 0 makes a slope equal 0. These two cards are very particular with that. Let's see, this card does not do that. Oh, and look at this one does, doesn't it? Do you see how on my y-axis here I've got a 0 slope again? Matter of fact, these two cards kind of match each other in a way for slope fields, because not only do I have a 0 slope on the y-axis in both cases, but I don't have any slope at all on the x-axis in either case. So this is particular to me. I think we've already been clear about the fact that you look for the slope, the horizontal tick marks, because horizontal tick marks means 0 slope, but a lack of tick mark would indicate an undefined slope. So we know that we have an undefined slope in both of these cases right here on the x-axis. The equation for the x-axis is y equals 0. So both of these slope fields, when you let y equal 0, the slope is undefined, which means I'm going to have some kind of a fraction with a y on the bottom for both of these things right here. So I'm just going to move this slope field away for a minute, and you see this one has a y equals on the denominator, and this one has a y on the denominator. So these differential equations have to match these two slope fields somehow. There's no other card for a differential equation that when you plug a y equals 0 in would give you something undefined. So I'm basically simply narrowing down my choices and using the process of elimination to match these up. Okay, so how else can I play? I'm down to 2. Something I notice here is this big X. Do you see this big X in the middle of this card? Well, that tells me that when you go up and down through the center of quadrants 1 and 3, the slope has a positive 1. And when you go up and down the center of quadrants 2 and 4, the slope is a negative 1. Okay, let's go back to quadrants 1 and 3 again. When you look at quadrants 1 and 3, and you go through the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, you can tell that the slope is a 1. Got that? So let's close this off. Let's open up the other one. If you do 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, you can tell that this slope is a negative 1. Okay? So let's just try it. Try, let's say, 4, 4. If I plug in 4 over 4 here, I get a positive 1. If I plug in a 4 over 4 here, I get a negative 1. That means that they're actually lined up appropriately. This differential equation will match this slope field, and this differential equation will match this slope field. Okay, we could do a little bit of extra information here, but dy dx equals negative x over y, you've seen repeatedly on AP Essentials videos, matches this slope field that look like concentric circles. So this is definitely matching. Pick any other point you want, test it. We could test the point, let's say negative 4, negative 2. So here I am, negative 4, negative 2. All right, at this particular tick mark. So at negative 4, negative 2, I'm going to put a negative 4 in for my x here, and I'm going to put a negative 2 in for my y here. So I have negative 4 divided by negative 2. That gives me a positive 2. But this negative on the outside turns my answer into negative 2 again. Come back to your slope field, and sure enough, that looks like a negative slope, and it's a negative slope that's steeper than negative 1. So yeah, there's your negative 2. Okay, they definitely match. So I'm going to pair this particular differential equation to this slope field and condense it. I'm going to move it over here. I'm going to pair up this particular differential equation to this slope field and condense it, get it out of my way. It's like crossing them off. All right, now what else do we have here? This is going to look familiar to me. Let's see what else I have for cards. I'm looking for something that is undefined. Do we see anywhere where there's no tick marks for a particular x or y coordinate? So I'm looking where x equals 0, I wouldn't have any slope. X equals 0 is the y-axis, isn't it? Oh, looky here. I see right here, you see this y-axis does not have any tick marks on it. And neither does this one. It was right there in my face the whole time. Both of these slope fields are undefined at, or have slopes that are undefined, I'm sorry, at x equals 0 or along the y-axis. So one of these matches. I'm just going to get these out of here. I'm going to move this over here as well. And I'm going to bring this down here and this down here. Now I might have to turn these around. Let's just take a look. What else is different about these? The x-axis has a horizontal tick mark, which means slope equals 0 when the y equals 0. Well, that would be true here. When y equals 0, your numerator will equal 0. When y equals 0, your numerator will equal 0. Of course, presuming x is not 0. And let's see what here. I see, you see this big X again, kind of like we did in one of the other examples. As you move through quadrant 1 and quadrant 3, the slope for all these points here straight up through when x and y are equal to each other or along the line of y equals x, you end up with a slope of 1. And along y equals negative x, you end up with a slope of negative 1. So I noticed those. I always look for my 0 slopes, my undefined slopes, my positive ones, and my negative ones, and those pretty much key in everything for me. So when x and y are identical, my slope is a 1. That's going to happen right here. So this matches. When my x and y are identical, my slope is negative 1 down here, and that is why this negative sign is on here. So yes, this differential equation is going to match this slope field. Let's condense it. This differential equation is going to match this slope field. Let's condense it. And let's drag these things over here, line them up as a pair. All right, so let's see what else we have. Anything conspicuous? Yeah, I see up and down here I have a slope field at x equals 0. I'm going to pull this over. I said I have a slope field at x equals 0. That's kind of silly. I have a slope of 0 in this slope field when x equals 0. Same thing here. Let's see, not the case up here, is it? So let's get this one over. Do we have any other? I think I can see all my cards here. Okay, pull them apart. There's 6 cards. Nothing else has a 0 along the y-axis except these 2. So now it's a matter of figuring out, okay, when x equals 0, my slope field would be a 0, or my slope itself would be a 0 in both of these. I can see that these 2 cards right here are going to suffice, and these 2 cards will match these 2 cards. So let's see how that works a little bit. I can move these away. I can put these side by side or up and down from each other so that these come here and here. All right, now either the x squared minus xy is going to match here or down here. And the reason I know that is because if I set my dy dx equal to 0 and I factored x squared minus xy, I would be factoring out an x, and my other factor would be x minus y. Down here, following that same procedure, I'd factor out an x and I'd have x plus y sitting in here. All right, well, if you factor out the x up here, you get x minus y. Take that x minus y, set it equal to 0, and it tells me that when x and y are equal, or x equals y equals x, your slope would be a 0. So I'm looking here, let me see, along this line, y equals x, I have a 0 slope, don't I? So that was my presumption. I put a 0 in here, set 0 equal to x squared minus xy. I like to write my 0 on the right hand side, so therefore I would say equals 0 on the other side. Factor an x out, get x minus y. Set each of those factors individually equal to 0 using the 0 product property. That would give me x equals 0 or x minus y equals 0. Solve for y in my second equation. That would give me y equals x. So sure enough, right along here, the y equals x, I have a slope of 0, which tells me that this differential equation will match that slope field. So let's see if this differential equation matches this slope field. And I will see, yes, indeed, it does by following the same argument, as a matter of fact. Put a 0 in for dy dx. We're wondering where we're going to notice horizontal tick marks by putting a 0 into dy dx. Factor out the x, you get x plus y in your parentheses, equals 0. So either x equals 0 or x plus y equals 0. Take the x plus y equals 0 and solve for y. You get y equals negative x. Sure enough, look right here. This is y equals negative x. This is where I'm going to have a slope equals 0. Anywhere where y equals negative x. And this is the line of y equals negative x. So this slope field matches this differential equation. I'm going to put the differential equation on top and condense. I'm going to put this differential equation on top of its slope field and condense. All right, and we're going to put these down here. I only have 4 cards left. It's not a whole lot. I'm going to be looking for my zeros. Do you see anywhere where we have some zeros here? I have zeros here. I have zeros here. I have zeros here. And I also have zeros here. And look, it just happens that, let me see, I think I would kind of like to match these 2 cards together. Does anybody see why? I know you're thinking y equals negative x over here, y equals negative x over here, maybe match these 2 cards. Depends on what you want to look for. But I am going to switch these, and I'm going to look at these 2 slope fields. I like them because I have x. When you're on your x-axis, the slope is 0. Down here, when you're on the x-axis, the slope is 0. So that's pretty simple for me. When I'm on the x-axis, that means that y equals 0. So let's move these out of here. I'll move this out of here. The x-axis has the equation of y equals 0. So I need to look over here and I need to figure out which of these differential equations, if you let y equals 0, do you automatically get a slope of 0? And you see how y is common in both of these terms? So factoring out a y, you'd factor out a y and get x plus y. Factor out a y, you get x minus y. Y equals 0 would make this slope equal 0, and y equals 0 would make this slope equal 0. So I'm going to push these away. Actually, if I were smart, I'd bring them right over here, because these 2 have to pair up here, don't they? All right, so I have 2 differential equations that have to match these 2 slope field cards. And likewise over here, I have these 2 differential equations that have to match those 2 slope field cards. So let's analyze this. These match, by the way, because of these horizontal tick marks along the x-axis. Gotcha. Okay. So I also have slope field up here. On this slope field card, I have a slope of 0 along y equals x. And down here, I have a slope equals 0 along the line of y equals negative x. So let's see what we have. Let's imagine putting a 0 in here, or if you're using paper and pencil, you can literally put a 0 in place of dy dx equals, I'm going to factor out a y on this side and give me y, open parentheses, x plus y. And again, I like to write equals 0 on the right-hand side. So that would give me the first factor, y equals 0. Got that in both of these. And in the second factor, it's going to say x plus y equals 0. So x plus y equals 0. If I solve for y, it's going to give me y equals negative x. That tells me that y equals negative x has to have a 0 slope, because that was the presumption I made when I let my derivative or my slope equal 0. This differential equation has to match this slope field. And let's channel the same argument up here and see why y equals x turns out to be the answer here as well. Factor out a y, and then you'll have 0 equals y times x minus y. Take your y, set it equal to 0. Take your x minus y, set it equal to 0 using the 0 product property. And the second factor here, where you have x minus y equals 0, that's where you'll get x equals y or y equals x. So that's going to work right here. Okay. Another thing you can do, I'm just going to, well, no, I'll just let that go. Let's just let that be our answer for that. Condense. Let's bring this slope field up on the top. My differential equation up on the top. Let's bring this differential equation up on top and merge it and condense. These 2 are definitely condensing here. So I'm over to these last 2. Let's see which one goes with what. I think it's pretty simple. You can just pick a point, maybe put the point into your slope field and see what it looks like. For me, it's even easier than that. I'd like to think of taking dy dx, setting it equal to 0. So I get 0 equals x minus y. Add y to both sides, I get y equals x. So my derivative or my slope will equal 0 when y equals x. See that right here? This has got to match because this line right here is the line of y equals x, and my slope is 0. See a little tick mark indicating a 0 slope, a little horizontal tick mark. So this differential equation matches this slope field. Do the same thing over here. This is going to match up here. I'm looking at putting a 0 in here. 0 equals x plus y, or x plus y equals 0. Solve for y. You get y equals negative x. So here we go. Y equals negative x. That matches there. Condense. Whoops, condense. This matches here. Go ahead and condense. And these pair up. Okay. Now let's just put them like this. Alrighty. So we are going to click where it says next. So we're going to go to page 2 and we're going to say check my work. Hey, are my slope fields matched correctly with my differential equations? Click on that. It'll think for a minute. I like this little wave going through. Yay, we got them all right. Cuckoo, cuckoo. You can go back and you can look at your slope fields and pair them up. I like to do this. I like to open them back up 2 at a time and make sure they look right. Convince myself about this y equals negative x line, this y equals x line. And you know, let's play with one more thing. Do you see right here on this particular slope field, do you see how this slope tick mark right here is a 1? The slope of this tick mark is a 1. Let's, instead of doing the 0, let's just take dy dx and say it equals 1. So I have a 1 here equals x minus y, and solve for y. That'll give me y equals x minus 1. And the equation of this line right here, where all of these tick marks have a slope of 1, is y equals x minus 1. You see the y-intercept down here of negative 1? Slope of 1? So it kind of matches as well. I could do the same thing over here. I could say, let's replace this dy dx with the number 1 instead of 0. So I'd put a 1 over here, equals 1. X plus y equals 1. That means that y equals negative x plus 1. And sure enough, you look here, negative x plus 1. See all these positive ones here? That's what I'm looking at. This one might be even better just to go negative 1. See this diagonal line right here? It appears it has a slope of negative 1. Put a negative 1 in for dy dx. So x plus y equals negative 1. Subtract your x from both sides of the equation, you get y equals negative x minus 1. And aren't all your negative 1 slopes along the line of y equals negative x minus 1? So it's kind of cool. Just compare those back and forth again. Bring them down. Oops, don't want that. Let's see. Bring this up. Open these up. You see how those compare? Notice that x is a factor here, so when x equals 0, I'm going to have a 0 slope field. Sure enough, x equals 0 is the y-axis, so I have a 0 slope on that slope field. Okay, just play with them a little bit. Look at them. Time yourself. See how long it takes you to get through the slope field card match and see if you can improve your time. It's kind of fun to play with. Open these up. We know they're right. We checked them already. Okay, and I'm just curious here. I want this one, I think. Yep. Whoops, I apologize. Close. I'm going to bring this up here, and I'm going to bring this one up here and open it up as well. These are all your fractions. Okay, you see this circle one? It's very distinctive, this circle. Very distinctive. Negative x over y. dy dx is negative x over y. Those are your circles. Here you got this big X. You got a big X over here too, but these are different because we're undefined on the X-axis here, where Y equals 0. Yeah, get out of there. And we're undefined over here on the Y-axis, where X equals 0. Okay, play around with those. They're kind of fun. The better you get at them, and the faster you can do them, it's just a matter of playing around. Play this game. Get better and better at your slope fields so that you understand them. And notice I'm trying to do this whole process of slope fields without literally plugging in points, but instead thinking about the slope field equaling 0, the slope itself equaling 0 or being undefined, or having a slope of 1 or having a slope of negative 1. Okay, notice that a y is a common factor here. So you factor out a y, you get x minus y. You factor out a y here, you get x plus y. But in either case, when y equals 0, which is your x-axis, the slopes are 0. Okay, play around. Keep saying that, but I'm just going to go through the last 4 quick like. Let's bring them up and open them. Let's bring them up and open them. Those are all x's, all x's. This one's upside down, so let's move that so that slope field's on top. Oh, so slope field's on the bottom is what I meant to say. And let's bring this one over here. And this is the only card that had just y's in it. So notice as you go left and right on this particular slope field, the value of the x is irrelevant. And that's why the x itself doesn't occur up in here. The slope field only depends on how high or low you go in this graph. Okay, plus and minus 4 here. You got the same thing over here with the x's, plus and minus 4, and no other horizontal tick marks. Make sure you play with that. It's not just I have to have horizontal tick marks at plus and minus 4 here, but I can't have any others. Okay? Here I have plus and minus 4, but I also have, when x is 0, I have a horizontal tick mark as well. This one here, factor out an x, you get x minus 4, so I have horizontal tick marks at x equals 0 and x equals 4. All right, well, I hope that is helpful for you. Play around with it yourself, see what you can do, and enjoy. Okay? Talent out, you guys.